depreciate mean? It goes down. Kevin, what else would depreciate?
Get worse.
Yeah, what gets worse?
Those
Most
things.
Water?
The value of something goes down over time.
Yeah, the value of something goes down over time. So all of those vehicles out in the lot, whatever it happens to be, none of them appreciate unless there's a really old vehicle, like maybe a Corvette from 1960. That probably has appreciated because they're so rare. But most of the vehicles out there, whenever you drive it off the lot, you're never going to get back what you paid for, kind of thing. Houses appreciate, cars depreciate. Anything with technology usually sad depreciates. Like my very old iPhone, I probably couldn't sell it for $5 because it's almost 5 years old, but it still works for now. So if you look at the constraints, Rebecca, what word did you use for constraint? A restriction. So a constraint is the same thing as a restriction. It's not recognizing my pen. There we go. What are the restrictions that you're given in this problem? Or constraints that you're given in the problem? Are you given restrictions for x or for y? For x, because t is really our x variable in this problem, but we're using t because it represents time. So when you're talking about a window, the viewing rectangle is literally where you see the graph when you hit graph on the calculator. So that little window where the graph pops up, that's called the viewing rectangle. But the window is the min and the max for x. But then we also want to talk about the scale. The scale would be those little tick marks and what they're counting by. So is it counting by 1, 2, 10, 20, 50? Whatever you decide will determine what each one of the little tick marks represents. So you can use these exact numbers. You can use 0 and 8. However, when you use 0 and 8, sometimes it kind of cuts off the calculator screen, and if there's an intercept there, you can't really see the intercept very well. So I like to go a little above and a little below. Is that wrong if you just use 0 and 8? No, not at all. But I chose to use -1 and 9. You could choose -5 and 15 if you wanted. But 0 and 8 have to be in between those values for you to correctly use those constraints. The scale, because these numbers are close, the scale would just be 1. Each one of my tick marks would count by 1. I wouldn't want them to count by 5s because then you kind of are just spreading your values out too much. So if you're using the constraints, and here's the goal, to use these values, you want to find y based off of x. So I don't want you to pick regular or just random y values. I want you to use those values to find what the y values would be. How do you do that? So how could you use the x values to find your y? Odette. So you can plug in 0 and 8 if you chose 0 and 8. You can plug in -1 and 9 if you chose -1 and 9. But you're going to plug in the numbers you pick for x into the equation so that your y values should kind of correspond with the numbers you chose for x. So that's kind of using a constraint to help you find the matching values for y. So if I use -1, we have 225,000 minus 20,000 times -1. Some of you can do this mentally, hopefully. What is 225,000 plus 20,000? Kevin? 245,000. Kevin, do you think that's going to be a y min or a y max? Yeah, it actually ends up being the y max. Still a pretty big number. So the minimum for x actually gives us the maximum y value. Because the graph is starting high and then it's going low as time moves on. So doing the same thing, if I use a 9, again, you can use an 8. You could have used 10. So now I have 225,000 minus 180,000. That ends up giving us 45,000. That's the minimum. The minimum should occur as time is passing. And this is those 8 years. So at 8 years, the molding machine is only worth $45,000. But I guess it's still worth something. The last thing is the scale. You don't want to count by ones because these numbers are in the thousands. So you could count by 1,000. You might want to count by 10,000 because this number is still pretty big at the top. So when you're thinking about that scale, how does it relate to the numbers that you have? Does that make more sense? We will actually be doing this a lot. So a lot of the equations that we work with will be larger because it's an application problem. So how can we try and quickly find some scales and max min values to help us solve the problem using the calculator? Were there other questions from the homework? Abby? I grabbed it. Yeah, so number 12, the first question said, explain. That's not it. So explain how to use a graphing calculator to verify y1 is equal to y2. Abby, how would you use a graphing calculator to show that y1 is equal to y2, the two equations that are given there? And then what should you get when you graph it? Yeah, the same line, the same curve, they should be exactly the same. So that's the explaining part. And then it says identify the rule of algebra. Nothing wants to work perfectly for me today. Well, you all can read what's on your page. Identify the rule of algebra that's illustrated. When you have parentheses in the problem, what rule is that, Connor?
The distributive property.
Yeah, that's the distributive property. So the rule of algebra would be the distributive property. Because you would then distribute the 2 through. You distribute the 1/5 with the 10 to get the 2. And then the last part of that question, it said to graph. So make sure you sketch a little graph below. So some of those had like a couple of things like asking you to do. The 13 and 14 wanted you to graph the equation and then again sketch it. So you're graphing it in the calculator, sketching it. Is everybody okay using the calculator to find an x or a y value? You're good now?
Yeah.
Okay.
Can you do 13B? I was a little confused.
Yeah.
I was good for the Y.
You were good for, yep. So looking at number 13, ooh, I have it right here. So we plug in the square root of 5 minus x. This is your picture. So again, draw me a picture. Anytime it says to graph, sketch a little picture so I can see what you are looking at. And then it wants you to find the corresponding x value if the y is 3. And there are a couple of different ways you could do that. What's one way you could find the x if you know y is 3? Odette?
I graphed another line where Y is 3 on the
Oh, that's perfect. That's great. So she said, for some reason, like my screen is just not, something's not right with my screen. So she graphed a second line at 3, because now we know y is 3, and there's that line. And then you can find the intersection, right where this line is connecting with the curve, by using that second trace feature. So excellent, that's one way. So I would do second trace, and then number 5. And then you hit enter, you hit enter, you hit enter, and then I get -4, 3. So that's one way. What's another way that you could find that value? Taylor?
I just did like second graph.
Yeah. So the other way you could look at it is by using the table feature. So my table has an extra value at 3 because I plugged in that extra equation. But right here, we have the y value is 3. We can see the x value is -4. So that would be another way. A final way would be to go back to the graph. I apologize that it's just not working right for me today. And you can just, literally, all I did was press trace, And then you can arrow your little blinking cursor left and right. So I can move it left. Suppose it moves left. There it goes. I can move it right, and you could probably do a little estimation as to when is y getting close to the value of 3. That would be more of like the estimating way. So Odette said plug in the number for y in the second equation. Taylor had the using the second trace or the second table feature to look at the table. Questions? Kevin?
I had a question on 15. So I wasn't sure where you could look for the negative forward because there were like two parts where like it could have been
So then if they're,
literally one. Like where negative forward has to do the
no, if
the
there,
little thingy.
yeah, if there are two spots where they'll use both.
Okay.
Yeah.
Okay, because I wrote down both, but like I was looking at the answer sheet.
It
and
didn't
saw
have
one.
both?
I don't.
Oh.
But I just looked.
Okay, yeah, use both. If there are two x values, use both. Yeah. Other questions? Oh, what's this? Yeah, use both. All right, so today we're going to do some factoring is fun problems.
Yes.
So in your packet, if you turn to the, bless you, factoring page, this should hopefully be another review for you to have with factoring. There's some factoring problems in that concepts for trade and pre-calc worksheet, and we're going to go over some factoring today. And it's not just basic factoring. So if you look at just like those 6 problems on that page, you see that there's powers of 4, there's equations that have 2 variables in them. So this just isn't straightforward factoring. But a little reminder when you're factoring, look at the GCF first. Is there a GCF? First question. The second question would be, do you have a binomial, 2 terms? If there are 2 terms, if it's a minus sign and they're perfect squares, then you can factor using the perfect square formula. The A minus B, A plus B pattern. So that's just a pattern that works when they're perfect squares and it's a difference. The last option would be use trial and error, which most people don't use trial and error. I think the AC grouping is probably the most common method that we would use because it's an actual method to use. Trial and error is picking a set of numbers, foiling it mentally, does it work? So that would be trial and error. So we're going to look at the first problem. See if you can check out that first problem and decide how to factor it. So is there a GCF? It is definitely a binomial, so that's probably the way we're going to factor. But do they have something in common?
Yeah.
Yeah, what do they have, Jacob?
3.
A 3. So we can pull out that 3. So that gives us 9x to the 4th minus 4y squared.
Does that happen every time you say that?
Almost, yes. Yes. And I could put my iPad or my laptop over there, but then I can't use the little Elmo thing, but maybe I just don't use the Elmo thing anymore because it doesn't speak very well. Yeah. So how does this factor then as the perfect square pattern? So we have 9x to the 4th minus 4y squared.
Since both of them are squares, you can split them.
So one's going to be a minus, the other one's going to be a plus. And then you're literally just taking the square root of both of them. That's actually what you're doing when you're splitting them. So Kevin, you would have then
You would have 3x squared minus 2y and 3x squared plus 2y.
so those quantities should be the same because when you're taking the square root, you're taking something that's the same, multiplying by it to get the 9x to the 4th. X squared times x squared makes x to the 4th. And then don't forget about the GCF. I think that's like a common mistake. You do the factoring, forget about the GCF in the answer. Can that be factored any further? No. no longer a perfect square. We only have a single y back here. So we can't take the square root of a single y. They don't have rational exponents, and we don't want them to be factors. So the second one, again, we have a binomial, but it's a to the fourth minus b to the fourth. So we're going to try and use that same pattern. How would that pattern work? Again,
We get a squared minus b squared and a squared plus b squared.
nice. So again, has to be a minus sign. You have to be able to take the square root of both of those pieces. And then it's a pattern. One is going to have a minus, the other has a plus. Before you move on to the next problem, is it completely factored? Is there anything else you can do to either one of those? Quinn.
You can take the first one and factor it into a minus b and then a plus b.
Yeah. So that first one is still a difference, and they're both still perfect squares. So we can continue and take the square root of that. Quinn, can you do that with the second one?
No, because
Right, it's a plus. So when it's a binomial, if it's a difference, then it works. When it's a sum, it doesn't. It has to be a difference. So you just keep the a squared plus b squared. Questions? So those two use the binomial pattern. The next two are similar. Number 3 should be the easiest one on the sheet because there's one variable in the problem and the coefficient in front is just a 1 as well. So this is really just the AC, that like shortcut method, because it has a 1 in front of the w squared. Jacob, how'd you factor it?
I did w minus 2 and then w plus 10.
Yep, w minus 2, w plus 10. You don't need to do any extra steps. You're taking the two numbers that multiply together to be negative 20, which is negative 2 and 10, and then those two numbers drop directly into your factors. You're done. So if the coefficient is 1, it's easy factoring. Looking at number 4, the coefficient is 6. There's that xy back in the problem too. So trinomial, this is step 3 or option 3. That means we have to use AC grouping. So multiply A and C. What is 6 times negative 15? Yeah, 90. Pick your two numbers that multiply to be 90, but combine to be negative 89. So probably negative 90 and 1. That'd be a good option. And then how does AC grouping work? Rebecca? Oh, you weren't raising your hand. But what do you do with those two numbers? What do you do next? Well, what would you write next?
6x squared.
Does the xy stay together?
Yeah, the xy stays together. Yeah. So the negative 90, your first factor, stays with x and y. The second factor is a 1. That stays with x and y. And then the last one is negative 15y squared. So whatever's in the middle stays in the middle. So xy stays together. And then Abby, what could we take out of the first pair? A 3x. Could you take any more than a 3x?
You can
Maybe
take
a 6?
6x.
Yeah, maybe a 6. Take out a 6. And if we take out a 6, I think we end up with x and a negative 15y. Abby, what could you take out of the second pair?
Y.
Yeah, just a y. And then again, we have that x and negative 15y. So the last step of factoring by grouping only works if the quantity in parentheses is the same. If it isn't, you did something wrong. Ours is the same, so we can group the two terms in front together. And by grouping those two terms in front, then they're multiplied by that single parenthesis x minus 15. So you can try number 5, because I think it's fairly similar to this one here. So just because there are two variables in the problem doesn't mean you panic. Still a times c, it's just those two variables are kind of listed with those middle terms. Mackenzie, what two values did you use? And then after you pulled out what they had in common, what was that last factored step that you got? Any questions about how she got that? So taking out what they have in common, your group should be the same. So the last one, that's a trinomial. We have 9x to the 4th minus 13x squared plus 4. So we have one variable, but that powers to the 4th. Again, doesn't mean you can't factor it. Factor it the same way. We have 36. What two numbers are we going to use here? Yeah, -9 and -4. So 9x to the 4th. And then just like over there, we use m and n. Whatever's in the middle is the variable that attaches with the two factors. So she said -9, that gets x squared. -4 also gets an x squared. So whatever's in the middle, when you're listing your two factors and choosing those correct factors, they also get that same variable. So Quinn, getting to this step here, when you take out the pieces they have in common, what do you end up getting them?
I had 9x squared plus 4 and then x squared minus 1.
You are super close.
9x squared minus 4.
There you go, yeah. Should be a -4. So we're taking on a -4 here with that second term to get the x squared minus 1. Both the 9 and the 4 are negative. So look at your problem. Is it factored? Dylan, is it factored? Why not?
Because you can take the square root of -1.
Yeah, so you can take the square root of each of them. They're both still perfect squares with a minus sign. So these are binomial perfect squares. So one extra step, 3x minus 2, 3x plus 2, x minus 1, x plus 1. The larger your power, the more factoring that's probably involved. So if I have a power of 4, I could have 4 factors when you're done. We'll really go in that chapter 2, we'll really talk about the powers and the factors that are related with the powers. How do we do with the AC and the binomial factoring? Good. Okay, so on the back, these are a little different because now we have more than 3 terms. So it says when you have more than 3 terms, use just grouping. So it's no longer taking A times C, but it's using the grouping process. I actually want you to do 8 and 9. We're going to come back to 7. So look at number 8, 4 terms. You're just grouping. So group terms together, factor out what they have in common. So 8 and 9, we'll go back to 7. So you're not doing A times C, this is just grouping. So Amber, what did you group here? Mhm. And what did you take out? And you get, and then the second pair, good. That's all that you do with grouping. So 2, you could pair 2 together, take out what they have in common. That's one way to use grouping. And then you pull the values together because those parentheses are the same. That's why you're allowed to group them together, because they're like terms. Like terms can be pulled together. So you can pull them together in a parenthesis. Looking at number 9, doing pretty much the exact same thing. xy minus 4x, negative 2y plus 8. Dylan, what could we take out of the first pair here? X, and that leaves you with?
X or y minus 4.
Good. And then the second pair?
Take out negative 2,
And you also get?
y minus 4.
Right. So x minus 2, y minus 4. But again, notice the common part, that y minus 4. So if you go to number 7, there are parentheses in this already. How would you factor this problem? It's not factored yet because there's a minus sign. Allie?
Do you have to distribute first?
Yeah, what would you distribute?
The 3x and then the negative 1.
Okay, so let's just distribute so that we kind of get it into this expanded form. So 3x squared y minus 6x squared. And then this minus 2, I'm going to just put back here because it's a number. Numbers always go last. And then the y turns into a plus y. So I just put the number last. Constants are always last. Allie, then what would you do?
And then can you group?
Yeah. So what would you take out?
A 3x squared.
And that one goes back to saying y minus 2, which, yeah, I know that's where we started. What would you take out of the second one then?
Just a 1.
Just a 1. And then you get that y minus 2. So 3x squared plus 1, y minus 2. There's a couple different ways you could have done that. You could have just chose to distribute this back number, the negative 2 through, and then you would have kind of been at this step here instead of distributing. Questions? So those 3 problems are all similar because you're grouping 2 pairs, the front 2 and the back 2. So you have 2 pairs that you're grouping together. And that works probably for like 95 out of 100 factoring problems where you're just grouping. The last one, I think Mrs. Lucas jinxed me. Her board went kaput. Actually, I probably jinxed myself, but I was like, no, mine's fine. And I don't know, I think my board's breaking too. So the last one here, we're going to use grouping, but we're going to use it slightly differently. And I'm going to help you a little bit here. We are going to group the first 3 terms together. That's a trinomial. It's a factorable trinomial. And I know a lot of you are saying, yeah, but there's stuff in the back that we could group together as well. But if you group those things in the back together, it doesn't get you anywhere. And sometimes you have to try something to see if it works in order to see like why it doesn't work. I'm almost out of time, so I can't let you try to see why it doesn't work. So I'm going to help you a little bit. Ignore the negative 9. How could I factor that trinomial? So pretend the negative 9 isn't there. We have x squared plus 4xy plus 4y squared. How would you factor that? What times what makes 4? 2 times 2. So we'd have x squared, 2xy, 2xy, 4y squared. I would pull out an x from the front, pull out a 2y from the back, and then I end up with x plus 2y, x plus 2y. What does that mean if the factors are the same? How could you rewrite it?
X plus 2y squared.
Yeah, since the factors are the same, there are 2 of them, I could write it as x plus 2y squared. There is something still to do because factored form means it should all be multiplication. And this isn't multiplication yet because there's a minus sign. Kevin, did you notice something?
Oh yeah, I was gonna say what do we do with the minus 9?
Yeah, what do you do about the minus 9? Odette?
Can you treat it like a binomial and take the square root of both?
Yeah, this is now a squared term minus a squared term. So we use grouping, but you use it differently. It doesn't always have to be the same type of grouping. So you're taking the square root of both. So the square root of here would be x plus 2y, and then the square root of 9, I would have a minus 3, x plus 2y, and then the plus 3. The square root of something that's squared is just that quantity itself. That one's weird, it's different. Again, you're gonna see like 1 out of 50 problems, or maybe 2 out of 100. They don't come around very much. Your homework is in that same packet. It's actually the next page. And within the next 5 minutes, I'll send the answers out, post them to Google Classroom, put them on their It's just the next page in your packet. There's a little quiz on Monday on factoring. Tomorrow and Monday, we're also going to be solving equations. So kind of reviewing some of the equations you've seen the last year or so. Yes?